Hello, my name is Thomas Waterman, and I am doing this presentation as part of the Computer Security course at MetroState University in Minnesota. Today I'll be speaking to you about blockchain technology and security with a focus on a brief history of the concept, how it works, current and future applications of the technology, as well as risks that are associated with the implementation of this technology on a broad spectrum. Due to the nature of the topics that I'm about to present, I am not liable for any damages that could be caused following the information in this video. So, to start off this presentation, what is blockchain? Well, many people know of blockchain technology thanks to the increasing popularity of cryptocurrencies, like Bitcoin. While Bitcoin does rely on this technology, a blockchain is more than just cryptocurrency. A blockchain is a distributed and decentralized database. More specifically, it is a completely public digital ledger of transactions that is maintained by a network of computers in such a way that it makes it extremely difficult, if not impossible, to successfully hack or alter. Blockchain is also referred to, and was originally known as, distributed ledger technology. To give a brief history of blockchain, in 1991, Stuart Haber, who was a cryptographer, and W. Scott Stornetta, who was a well-known physicist and scientific researcher, created distributed ledger technology as a means to timestamp digital documents in a manner that cannot be altered, backdated, or tampered with. These two individuals continued to work on the concept, and in 1992 integrated a Merkle tree, which is a type of data structure, into the blocks of data themselves, thus allowing single blocks to contain much more information at a time. Fast forward from the year 1992 to the year 2008, Bitcoin was introduced to the world and was the first real-world application of digital ledger technology. Bitcoin was not created by Haber or Stornetta, though. The blockchain concept was adopted and implemented by Satoshi Nakamoto, who is accredited with inventing Bitcoin. Little is known about Nakamoto, besides the fact that it is believed that Nakamoto is not actually one individual, but a group of people who collectively worked together to create Bitcoin. Bitcoin and other cryptocurrencies are the main implementation and usage of digital ledger technology as of today. So, how does blockchain work, and what makes it so secure? Well, blockchain gets its name from quite literally being a digital chain of blocks where each block contains information. The chain itself is essentially a linked list data structure, which consists of nodes, and where each node holds information and knows of the node that came before it in the list, but now also introduces cryptography into the picture. Each block in a blockchain contains a set or sets of data, a hash code of that block, and also the hash code of the previous block in the chain. The hash code can be thought of as a unique identifier of the block, almost like an ID badge. The hash code is unique to each block because it is derived using complex mathematical formulas on the actual data set that is held within the block to give all of that information a single numeric value. Because of this, no hash can be repeated within a blockchain, and so acts as a perfect ID for each block. Any changes made within the block would therefore then change the hash itself, and because each block knows the hash of the block that came before it in the chain, any changes made to a single block must then have all hashes recalculated down the chain from that block, or the chain would fall apart. Thus, it becomes easily detectable when any changes have been made to any block. Blockchain networks are distributed and decentralized peer-to-peer networks. What this really means in basic terms is that anyone and everyone is allowed to join, and the network itself is not based at any single location. When someone joins the network, they get a full copy of the chain. Each time a new block is created, that block is then added to everyone else's chain on the network. Each node of the network then verifies the accuracy of information of the block, including information of the previous blocks, to make sure that it has not been tampered with. If all nodes verify that this is accurate, the block is then added to each blockchain. By having this distributed network where each node of the network verifies the block before adding a blockchain to the chain is using what is referred to as a consensus. This constant verification that takes place from the consensus protocol is what ultimately makes blockchains so secure. If someone were to attempt to alter the information of a block in a chain, that block would then be rejected by other nodes in the network because it does not match their blocks, and thus the chain would not be changed. So, to successfully alter a block in a blockchain, an individual would have to accomplish a very challenging task. The malicious actor would need to not only identify and alter the block containing the information they want to change, but also do so for every block on the network simultaneously. To accomplish such a task like that, the individual would need to take control of the majority of network's nodes, so that by altering all nodes that they control, the nodes outside of the attacker's control become the minority, and by the consensus protocols, update their information to match other chains. In a network that is completely decentralized and completely public, therefore growing every day, this task is nearly impossible. So, what are some possible positive implementations of blockchain technology and ways to use this beyond cryptocurrency? Well, the medical industry is one that could greatly benefit. Falsifying medical records is considered to be a felony. And while electronic health record systems do have procedures to document and legitimize and monitor changes to electronic records, falsification still happens in the healthcare industry. One of the most common reasons is attempting to cover up known errors to avoid lawsuit, while other reasons include removing significant facts and even creating records for non-existing patients. Blockchain could also provide huge stability to the realm of personal identification. Identity theft is a huge issue on a global scale. Passports, driver's licenses, social security cards are continuing to evolve and become harder to tamper with and forge than previous years. But with the growing technology of how these documents are created, also grows the technology used to falsify these items. With blockchain being decentralized, falsifying an ID on this would be nearly impossible, as any attempt to alter this ID would mean an alteration to an entire network. If the network were to be global for something such as a global ID, this would almost certainly be impossible by today's standards, therefore protecting an individual's identification. Now that we've covered some of the possible benefits of implementing blockchain across multiple industries, what might be some possible risks that we need to consider with implementing this more? One risk with blockchain is also part of what makes it so secure. That is the consensus protocol. While it would be extremely difficult for a single person or a small group to take control of the majority of a network, a large group of attackers only need to gain 51% to control the majority of the network and therefore control the consensus protocol. Think of recent attackers like the Dark Side group that was recently holding up the entire oil industry with ransomware. A group that large attacking a smaller network is a considerable threat. Another risk that seems general is the fact that the system has yet to have any long-holding standards set in place. The lack of international standards leaves many gray areas open to interpretation as blockchain becomes more and more adopted. Different frameworks continue to be introduced, and with those also lies a lack of adequate time for proper code testing, as many blockchain developers are trying to simply keep up with the growth and the increasing public interest in blockchain. One more important factor to consider is the sheer amount of energy required for distributed ledger technology, also known as blockchain. Because the network is decentralized and because of the proof of work that is used to verify the additions to the blockchain, the sum of energy used is, well, let's just say it's extreme. For example, Bitcoin's mining network is currently estimated to use more electricity in a year than the entire country of Ireland will use in that same year. We have to be mindful of how exhausting this is on our resources if we were to implement blockchain across multiple industries. In summary, blockchain is more than just cryptocurrency. This is the concept of a distributed and decentralized database that is completely public and available for anyone to join. Because of the decentralized nature and the consensus protocol, blockchain technology seems to be one of the most secure ways to handle many different types of data in the world we live in today. It is nearly impossible to tamper with information in a blockchain given a large enough network. There are downsides to this, though. The technology is new, and there aren't any international standards set in place yet regarding blockchain. The energy resources needed to maintain a blockchain network are exhausting, and while it is extremely secure across large networks, the same technology could be taken control of by large groups across small networks. Thank you all very much for your time in listening to this presentation. I very much look forward to your responses and thoughts on this topic.